Greetings everyone, and welcome to my channel. In this video, we are going to talk about linear regression. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables. It assumes a linear relationship between the independent variables and the dependent variable. The goal of linear regression is to find the best fitting line that minimizes the differences between the predicted values and the actual values of the dependent variable. The equation for a linear regression model is represented as y equal a plus bx, where y is the dependent variable, a is the intercept, b is the slope coefficient, and x is the independent variable. The intercept a represents the value of y when x is equal to 0. It indicates the starting point of the linear regression line, which is the point where the line crosses the y-axis. The slope coefficient b represents the change in y for every unit change in x. It indicates the steepness of the linear regression line, which is the rate at which y changes with respect to x. Let's say we want to predict the income of a person on their age. We collect data from 100 individuals and create a linear regression model with the equation income equal 5,000 plus 200 times age. In this equation, the intercept A is 5,000, which means that a person with an age of 0 years would have an income of $5,000. The slope coefficient B is 200, which means that for every 1 year increase in age, the income would increase by $200. Using this equation, we can predict the income of a person based on their age. For example, a person who is 30 years old would have an estimated income of $11,000. Now let's implement a simple linear regression example in Python using NumPy and scikit-learn libraries. Firstly, we import the necessary libraries including NumPy for numerical operations, matplotlib for plotting, and linear regression from scikit-learn for linear regression modeling. In step 2, we create a simple dataset with one independent variable x and one dependent variable y. In this example, we have x as 1, 2, 3, 4, 5 and y as 3, 4, 6, 7, 8. Step 3, we create an instance of the linear regression class, fit the model on the dataset using the fit method. So, step 3, create and train linear regression model. In step 4, we create a new data point, x new for example, that we want to make prediction on using our trained linear regression model. We create a NumPy array 6 to represent the new data point. However, since the predict method of scikit-learn's linear regression model expects a 2D array as input, we need to reshape it using the reshape method. The -1 parameter indicates that NumPy should infer the size of that dimension based on the other dimension and the number of elements. In this case, it automatically reshapes the array into a single row 2D array. So, step 4 makes predictions. The predicted value is 9.5. Y underscore new equal to model.predict x new. In this line, we use a trained linear regression model to predict the target variable y for the new data point x new. The predict method takes the new data point as input and returns the predicted value. The predicted value is assigned to the variable y new. To summarize, the code snippet takes a new data point x new that we want to predict using a trained linear regression model. In step 5, we visualize a linear regression line by plotting the actual data points on a scatter plot and the line of best fit predicted values using plot. The x-axis represents the independent variable x and the y-axis represents the dependent variable y. Let's go for step 5 as we visualize the linear regression line. Plot.scatter x, y, color, people, blue. Label, equal, plot, x, model predicted, color, red, label, linear regression. As here we can see, we plotted the points of the data with the linear regression line. The code demonstrates a simple linear regression example where there is one only independent variable. If you have a dataset with multiple independent variables, you can modify the code by providing a 2D array to the x variable and making predictions accordingly. Feel free to modify the code to fit your specific dataset and explore different aspects of linear regression, such as model evaluation and diagnostic analysis. Thanks for watching. I hope you enjoyed the video. If yes, then please don't forget to subscribe to our channel, hit the like button, share the video, and leave your comments under the comment section. Until next time, happy analyzing.